Okay, we're working backwards with the area formula in trigonometry. We did a first example, we got an answer of 30 degrees. Second example, if the area of this triangle is 17 centimeters squared, we've defined x corrected 2 decimal places. So what we have here is a triangle where one of the sides is 8.6 long, the angle is 120 degrees, and this is x, so this is a mystery. So x is one of our arms. If you can see, there's an arm, and there's an arm, and there's the so-called hug angle. And we're told that the area is 17. So we're told that the area is 17. So we write down area is a half times our first arm by our second arm by the sine of our hug angle. Now in this case, our first arm is x and our second arm is 8.6 and our sine 120, like that. So I'm able to write down a half times x times 8.6 by the sine of 120 is equal to my answer, which is 17. Now there are different ways of doing this, but we can't put x into the calculator. However, we can multiply a half by 8.6 by sine 120. We're able to multiply the half by the 8.6 by the sine 120 and then just put an x beside it. So that's what we do. We put in a half, which is 0.5 by the way, multiplied by 8.6, multiplied by the sine of 120, and press equals. And up comes this fancy surd. If you want to change it to decimals, you can. Probably not a bad idea. Now it's 3.7239. I'm going to leave at least 4 decimals in until the very end. So I'm going to have 3.7239. Don't forget your x. Multiplied by x is 17. Now we've formed an equation. It's very important that you leave lots of decimals here until the end, otherwise your answer won't be as accurate as it ought to be. So 3.7239x is 17. So how do we get x on its own? Well, the 3.7239 is being multiplied, and the opposite of multiplying by 3.7 is dividing. So it's going to be 17 divided by 3.7239. And all we have to do is do that sum in our calculator. So we get 17 divided by 3.7239, double check we typed it in right, and then press equals, and up comes 4.565. 4.5651. Now they want this answer corrected 2 decimal places, so my answer is x will be 4.57 centimeters, and that there is the answer to this example. Next, last example, example 3. In example 3, they tell us that the area of this isosceles triangle is 8 centimeters squared. So they're telling us the area is 8. Find y, correct to 1 decimal place. Now, if we look at this picture, there's a y here. Notice these 2 marks here and here mean that these are the same size, which means it's an isosceles triangle. This is 40-degree angle in here. So if we look at arms for our area formula, this is one arm, and this is another arm. So, and then this would be the hug angle, which is 40 degrees. So what we're able to do is we're able to say a half multiplied by my first arm, which is y, multiplied by my second one here. We don't seem to know what this is. But because it's isosceles, we also know that this would be y long as well. So let's put another y. So it's half times y times the sine of 40 degrees must equal the area given in the question, which is 8. Now, we can't put y's into our calculator, but we can say y times y is y squared, and we can multiply a half by sine 40. So let's multiply a half by sine 40. 0.5 multiplied by sine 40 equals 0.32139. I'm going to round that to 4 decimal places. So I've got 0.3214 times y squared, because y times y is y squared, equals 8. Now I have an equation. I want to get y squared on its own. To get rid of a multiply by 0.3214, I divide by 0.3214. So it's going to be 8 divided by 0.3214. So let's do that in our calculator. 8 divided by 0.3214 equals, and I'm getting 24.89. So 24.89 98911. I'll write a few decimals. And then y will be the square root of that, because to get rid of a square in maths, we square root. So y will be the square root of my answer. So I can leave the answer on my screen and just press the square root key and press the answer key. That's a quick way to do it. And it's 4.989. 4.989. Now they want to correct to one decimal place. So this one will actually round up to 5.0. And it's the units. They didn't give us units here, so I can leave it as units. So that there is the answer to that. So look at your textbook. There are similar examples using doing questions like this, where you're given the area and you're asked to work backwards to find a side or an angle. So have a look at those, please.